So today we are going to discuss about work energy principle. This principle is very much applicable in solving numericals related to work and energy. So this principle says the work done by all the forces. So work done by all the forces acting on any object is equal to gain in kinetic energy of the object. So here we have to consider all the possible forces which are acting on that object. In that case, if we calculate the work done by all the forces, whether it is positive work, whether it is negative work, what type of work are done by all the forces, then that force will be always equal to, that total work done will be always equal to gain in kinetic energy. Gain in kinetic energy means final kinetic energy of the object minus initial kinetic energy. So this is the principle. We will prove this principle and we will see some example of how we can use it. So in order to prove it, we are considering this object which is placed on this smooth horizontal surface. Smooth surface means we are not going to consider any friction. So this surface is smooth. The object is placed here. Now when we apply an external force F, the object will start moving. Now when we have not applied the force, the two forces are acting on this object. One is the force of gravity, that is the weight of the object, which is equal to mg. Other is the normal reaction, which is applied by the surface in order to keep it balanced position. So this normal reaction and weight will be equal, either means it is not neither moving up nor going down. So these two forces are equal. Due to these two forces, no motion is produced. But this external force F is producing, giving a constant acceleration, as the force is constant, so acceleration will be also constant, and it acquires a velocity v after covering a distance s. So we have written here, consider an object of mass m placed on a smooth horizontal surface. Let a constant external force F be applied on the object parallel to the surface. It is applied this way, not inclined one. Parallel to the surface, due to which the object acquires a velocity v after covering a distance s. So when object has displaced from A to B, a distance s, its velocity increases from u to v. So we are going to prove whatever work is done by all these three forces will be equal to the gain in kinetic energy. So what will be the gain in kinetic energy of object? So gain in kinetic energy of object will be half mv square minus half mu square. As u is 0, so it will be half mv square only. So this is the gain in kinetic energy of object. Now we will find the work done by all the forces. Now before that we will find the acceleration. Since this v square is u square plus 2as, this v square will be here, u is 0 plus 2as, where is acceleration of object. So this A will be equal to v square over 2s. So this we are saying, this is equation number suppose 1. So we got the acceleration, we got the gain in kinetic energy. Now we are finding the work done by all the three forces. So work done by normal reaction. What will be? Work done is given by force into displacement Fs cos theta, force into displacement into cos of the angle between force and displacement. So here it is R S cos. The normal reaction this side, displacement is this side. So angle between R and S is 90 degree. So it is cos 90. So this will be 0. This work done we are calculating when object is displaced from A to B. Normal work done by normal reaction when object is displaced from A to B. This is 0. Similarly, work done by gravity. Here gravity means what? Weight of object, which is mg. That is gravity. Again same, when object is displaced from A to B. Now in this case also, so in this case also what is happening? Work is, that is W is acting, gravity is acting downward, displacement is acting horizontal. Again, angle between force and displacement is 90 degree, cos 90. So this work is also 0. So work done by this force, work done by this force, both are 0. Now we are going to find what is the work done by this external force F. So work done by external force. This is F into S into cos 0 degree, because we have applied the force parallel to the surface. So angle between force and displacement is 0. Displacement is in the direction of force. So angle between force and displacement is 0. So this is F into S cos 0 0 1 only. Now in place of F we can write mass into acceleration. So this F is mass into acceleration, where A we call acceleration of the object. As force is constant, so acceleration will be also constant. Now acceleration we have got in equation number 1, we have got the value of acceleration, and that was m v square over 2s into s. So from equation 1 we have A is v square by 2s, that we have got already. So this s just will cancel, so it will become half mv squared. Now we will calculate work done by all the forces. According to the principle, we have to prove work done by all the forces is equal to gain in kinetic energy. So work done by all the three forces, we have considered here three forces only. Three forces are acting. So work done by all the forces so it is work done by R, that is external, normal reaction, work done by W, force of gravity, plus work done by external force. So work done by R, we have got it is 0, work done by W, that is also 0, and work done by this external force we have got half mv square. So this is half mv square, and we have already got previously, that is this half mv square is gain in kinetic energy. So this is gain in kinetic energy. In this way, we have already proved work done by all the forces, or total work done, we can say total work done by all the forces is equal to gain in kinetic energy of object. So this is work energy principle. This principle is very important. By using this, we are solving so many numericals. In class 10, very few are there, but in class 11, so many numericals are based on this principle only. So we will discuss one example here now. So here you are given, this is an inclined plane, or the shape of this one is of surface is like this. So when object is placed here, it is placed on inclined plane. Suppose it is this way, it is kept inclined. What will happen? The object will start slipping, so it will start sliding. This height is given from vertical, it is given from horizontal, it is 10 meter. It starts moving from this point A, and when it reaches at point C, it acquires a speed of 6 meters per second. Now you are asked, what is the work done by friction? So work done by friction you are asked here. Now what are the external forces acting on this object? So again, three forces, but two forces here only. One will be this force of gravity, that is mg. Other is the normal reaction which is acting perpendicular to the surface AC. So we will use here again work energy principle. So what is work done by gravity? When object is displaced from A to C. So force of gravity is mg. You can apply, okay, if you are thinking, okay, I will apply mg, fs cos theta, then suppose this is as mgs into cos theta, then theta will be this much. This is the displacement and this is the angle. So this is theta, angle between this and this. Or it will be simply mgh. As cos theta, you will find that will be h only. So directly we can apply when the work done by gravity means mgh. So either directly you will apply, or you can, if you are applying this one, Then also what will be this cos theta is what? H over S. So H by S, SS will cancel. So mgh. So this one is mgh. Okay, mass of object is not given. So if speed of object of mass, we can say of mass 5 kg. So suppose mass is given 5 kg into 10. So this is 500 joule. Now work done by normal reaction. R into S into cos 90. So it is 0 because normal reaction is perpendicular to this displacement. Displacement in this direction, normal reaction, so it is 0. Now work done by friction we have to find. So let work done by friction be x. Now if we apply work energy principle, then what will be? So according to work energy principle, as surface is not smooth, so there is friction, and friction work done by friction is also asked. So naturally this friction is acting this side, which we have to find. Work done by friction we have to find. So according to this principle, what will be? Work done by all the forces. So work done by friction plus gravity plus normal reaction will be equal to gain in kinetic energy of the object. So work done by friction, this we have to find. Work done by gravity we have got 500 joule. Work done by normal reaction was 0. So this will be equal to half mv square minus mu square. U is 0 only. So if mass is not given, then also we might have got the same. Okay, will it be? So x plus 500 will be equal to half into 5 into 6 into 6. So this x is 180 minus 500. So it is minus 320 joule. We are getting minus. Why? Friction will act in this side, displacement is this side. So work done by friction will be always negative. So answer will be work done by, as you are asked, work done by friction, not against friction. If it is asked what is work done against friction, then answer will be plus 320. Work done by friction, so minus 320 joule. Friction is here not doing any work. So by this example it is clear how we can use this theorem for calculating in different cases. How will you calculate work done, or how will you use this principle? Sometime work will be given, kinetic energy is asked. Sometimes loss in kinetic energy of object will be given. You will be asked work done by the force or against force. Then we can easily use it. Okay, thank you. So I think it will be very clear to you.